There are many changes occurring in today's aerospace workplace, but one of special importance is the kind of thinking technicians are being asked to use as they do their jobs. In the past, technicians were trained in narrow specialty areas, and they worked in those disciplines almost exclusively. In my case, I was trained as an electrical technician and knew little about other areas like structures or hydraulics. Today, technicians are being challenged to become more knowledgeable in many areas of expertise. They not only need to know how to work on their systems, they also need to know how their systems work. One method to understand the critical thinking skills we use when we troubleshoot an entire system rather than just one part is built on what is called systems thinking. If you learn to use this technique, it will help you in every situation you will ever encounter. This slide shows a simple diagram called the General Systems Model. It consists of 4 basic elements: inputs, outputs, processes that change inputs into outputs, and feedback loops to compare intended outputs with actual results so changes can be made to ensure the system is operating properly. A great example is a thermostat for an air conditioning system. It looks just like the General Systems Model, comparing the actual temperature with the set point and calling for cool or warm air to bring the system into balance. The systems model came out of biology and was used by scientists to study and understand how living systems work. Your body could be described as a system that defines how you operate, your processes, your limitations, the range of outputs, and how much you need to do each task, the required inputs. Systems models are very flexible and can be divided into subsystems that allow us to get down to very detailed analysis of the tiniest part of almost anything: a car, a spacecraft, a school, a fruit fly. All these can be described using the same general systems model and the process of thinking of things in terms of input, process, output, and feedback. To use the model, just think about how you go about solving problems or troubleshooting when an operation doesn't work like it should. If your car won't start in the morning, you begin by deciding what's wrong with it. From the systems model, the way to do that is to start at the output end of the model and work backwards to the input. That rule works every time and gives people who use the systems model a real advantage in understanding system operations. When we analyze almost anything, we start by looking first at what is being produced, the output, to determine whether the system is working as it should be. And if it's not, we work our way through the process, then eventually to the input, to decide where the problem lies. In the workplace of the aerospace technician of the future, systems thinking and broad knowledge of aerospace system operations will be the dominant approach in shaping what technicians do and how they interact with one another. If you can begin to use the systems model in your thinking, you'll be way ahead of the game.